Hello guys, and welcome back to a brand new episode. I'm very excited to be recording this video. We're going to be creating a HTTP server in C, not really from scratch, but almost, well, yeah, completely from scratch. I mean, we're effectively going to be building on the last episode. For those of you who didn't watch the last episode, which I'd be quite surprised actually, because we gained over 200 subscribers from the last video alone. So for those of you who watched that video, thank you very much. Thank you for the support, and thank you for following along with this channel. For those of you who are new, I'm trying to effectively learn C from start to finish, and I'm kind of documenting my journey on doing that. I know it's an unrealistic goal, but albeit it's quite a fun one. So we're just going to kind of carry on with it and see where we go. Right, so for those of you who watched the previous episode, you would have seen that we created a TCP server and a TCP client in C. We got them talking to each other, where effectively the server would just print a hello world message to the client. It was all done through the terminal, and it was quite fun. And we followed Bij's guide, by the way, and I got to give complete credit to that guide. It is fantastic, and you guys really should go ahead and follow that guide, because you'll learn much more than you will from watching these videos. So, you know, join me and, you know, come along with me on this journey, but also make sure you have that guide open in another tab, because it'll just be very valuable for you to read that as well. And we're no doubt going to refer to that as well in this episode. So what I thought we would do to start then is briefly kind of pick up on where we left off last time. So you can see that we've got this file main.c here, and it is effectively a complete copy of what we had done in the previous episode, or what is found in Bij's guide. I'll put a link to the exact chapter in the description, so you can just copy and paste it and kind of follow along if you can't be bothered to kind of go over the previous episode we watched. Okay, we're just going to edit the server file. Okay, I've called it main.c, but we're just going to edit that effectively. All right, and once we've edited that file, what we're going to do is effectively allow us to connect to the server via the browser and just print some simple HTML. Okay, it's going to be static. It's going to be very bare bones at the start, and then we'll slowly add more and more to it. Okay, I'm going to go over this file for those of you who knew. For those of you who aren't and you want to skip a little bit ahead, feel free. Okay, but if you're a beginner, I suppose there's a little bit of value in this. Okay, so the first thing that I want to talk about then is the includes at the start. Now again, I'm going to be talking through this program as best as I can. It's been a while since I've looked at it myself, so we're going to kind of just breeze over this. Okay, so apologies if you're a bit more advanced and you know, again, just skip ahead, it's fine. So the first thing we have are the header files. Okay, so for those of you who are completely new to see what are header files, they're literally other bits of code that we can use in our program. Okay, so you can see we've got standard input-output library at the top. We got standard input-output, stdio.h. That allows us to use printf and different functions like that. We also have standard libraries, so stdlib.h. Okay, so these are pulling header files then. Okay, it's effectively telling the compiler where these functions, where these types are, so that we can use them in our program. You don't write these yourselves, so they're all done for us. Okay, and you can see that we have a lot more here. So we have socket.h, types.h, which are necessary for us to do some network programming. Okay, so I'm not going to go over each of these individually. I'm sure the Bij's guide would do a better job of that. Okay, but let's just kind of breeze through things. Okay, just give ourselves a bit of a reminder. And again, if you're new, you might find some value in this, and I know I certainly will, just kind of going over it myself, because I've completely forgotten what we're doing. We have preprocessor defines then. Okay, so these are known as macros. Right, now somebody may correct me and be very technical, because I know C is a highly technical language. I know the people who are experts in it really do know this stuff. I am not one of those people, so not yet, but we will get there. Okay, so defines then. Okay, so quite literally all I'm saying here is wherever port is found in my program, replace it with the string. Notice how I say string and not number. 3490. Okay, so that's the port that we're going to be connecting to. It's just effectively preprocessor macros. Okay, just makes our program run much faster. I don't think that modern C encourages them. They were used a lot back in the day. I don't know whether they use as much now, but you know, we followed Bij's guide. We kind of went along with that. Okay. The reason why I mentioned that port 3490 is a string is because I think the function get address info requires you to use a string and not the number 3490. So that's just an important thing to note there then. Okay, next thing we're going to move on to then is the sigchild handler. So again, this is effectively a signal interrupt. So whenever a particular event happens, we're going to run this code at some point in our program, okay? So for the general analogy that I use for people who are trying to understand signals is that there's two different ways to do things. You can poll, which is effectively where you're constantly, I guess a good analogy would be like your phone, okay? So say now you get a text message, you know, there's a few things that you could do. You could constantly look at your phone to see if you've received that text message, which would of course be time consuming and waste CPU time. I don't know if this is a good analogy for just going over a simple signal, okay? But so that is one thing you can do. Or you could have a signal that would appear like a text message, like a vibration or something that just notifies you, okay, this is done, or something's happened here, I need to look at it. Okay, so that's the general idea behind a signal. That's what it's doing. It's providing us with a bit of a, you know, it's effectively telling the computer something's happened, trigger this bit of code. Okay, so we call a signal in this program. I'm not going to go over the specifics of it because, like I said, I'm breezing through this and I can't really remember. I know the void s, we're typecasting s, which is an integer, to void because we're not going to use it. I know that much. And by the way, typecasting just means we're turning one data type into another effectively. I think that's the best way to describe that. Error number then, saved error number. I believe we're saving it just because it could change while we're executing this bit of code. I believe that's the purpose, but that's the general idea then, okay? And then we also have then wait PIDs, just cleaning up the zombie processes when fork creates a child process. So I've done a video explaining this in the past, okay, but for those of you who are new, okay, fork is effectively where we have our main program running and we can create a child process inside our program. So we're creating an exact duplicate of the main program, but it can go off and do its own thing effectively, okay? So that's what that's doing, and we do this in this program because imagine, you know, we have a server, you know, we have a main program running, and whenever a child, I don't think this is the most efficient way of doing it. You would probably typically do this in threads, but the general idea then is that, you know, you have your main program running, somebody joins the server, and we create a fork to deal with that, whatever is going on, okay? That's the general idea. So WNO hang then, okay? So this bit here means don't block if none are ready. So the while loop, which we'll see below then, keeps going until all finished children are cleaned up. So get address get in address then just a helper function, just effectively returning whether the address is IPv6 or IPv4. That's all that's doing, okay? We can see we're casting again, but here it looks a bit messy, it looks a bit confusing if you're new. Just typecasting there then, okay? So moving down a little bit, then we're going to come into the main program now. Okay, I mean, you can see we've set up a bunch of different variables. So these are very, again, there's a lot there. There's a lot to take in. We have our file descriptors, which is effectively just pointing to the socket. You know, I think this is going to be our file descriptor then, and this is going to be whoever is connecting to us. Okay, so that's just a general idea there. Memset is quite interesting. Okay, we're setting all the values in the hints, the structure that we've created up here, okay, for address info. Effectively, that's just set in the kind of what type of communication we want to have, which is AF, INET, and TCP, and setting the flags to passive. Again, you know, beginner here, so, you know, I'm not entirely sure what they are, but I know that this means IPv4, I believe this means TCP, and setting the flags to passive. So AI passive with null as the first argument to get address info means bind to all available network interfaces. That's what that means then, okay? Right, so moving down then, okay? Not going to really go over this, so getting address info, and then we are effectively binding to a socket here, okay? And if I scroll down a little bit, we free that once we're done with it. If we get an error, we say fail to bind. If listen, if we get an error when we're listening, then we're going to just effectively send an error message again. This is the signal handling that I was talking about earlier, okay? Pardon me, for the child processes. So that's that, and then effectively we just run our program. So this bit of code here really is what we're going to be running on the TCP server and client, or what is going to be soon our HTTP server. So we're going to do that very, very shortly, okay? Few things you might wonder as a beginner is, while one, that's effectively just saying this is an infinite loop. We're going to run this until, effectively whoever is in charge of the server will shut it down. Okay, so that's the general idea there. Now, I don't think there's anything else I want to go over. Here's fork. Okay, so again, that's the child process, which we are creating when somebody joins our server. Okay, so I believe that's all I wanted to talk about for now. Okay, so what I'm going to do is I'm going to effectively try to convert this file, which you can copy and paste from Bij's guide. I'm going to effectively change bits, tweak bits, and we're gonna get this running in the browser. Okay, and then what I'm hoping to do then is deal with different types of HTTP requests and so on. Okay, now there's some bits that I'm going to be a bit shaky on, so we're going to kind of figure this out together. So let's do that. Let's get started. Few things that we want to do then. Okay, so the first thing we want to do is effectively, I want it to be so that I can specify a port. That's step number one. Okay, so we're going to get rid of this line here. Okay, we don't need that. All that line was doing was effectively saying what we're going to keep backlog 10, but all that line was doing previously is effectively filling in get address info. So I'm going to change that now, and I'm going to change it to a port which doesn't really matter. We're going to say 3000. I think I have to do that in the form of a string because we did that when we were effectively predefining it as a macro. So that's it. That's the only change I'm going to make up here, and I think then we can just literally come straight on down, and we're going to change what the response is going to be. Okay, so whereas before we had hello world, we're actually going to create our own little response. So let's go ahead and do that now. Let's go in here. Again, I'm going to be very rusty, guys, by the way. This is my first time, I'm not kidding, programming in a long while. So we're going to do this. We're going to change that to response, and now we've got to create a response. Okay, and it's quite actually simple to do this. To just simply get it working in the browser. In fact, I think you could have just simply, if you just made that simple change that I've just made now, saved your file, type in, run the server and type it in your browser, you'll get something, you'll be able to connect to the server in effect. But we want to, effectively respond with some HTML then, okay? So we're going to do this using HTTP. So let's do this now. So we're going to do const char response. We're going to do equals, and then let's get this going then, okay? So I'm going to try and explain this a little bit afterwards, but just follow along for now. And again, I'll try and explain it as best I can. I'll even do a bit of looking up because there's some things here which I'm a bit uncertain on. So we're going to say HTTP 1.0, and we're going to say 200 OK, and we're going to use, I think it's \arm\n, but I could be wrong on that. I could very well be wrong on that. We'll double check that later. Right, it's probably best that I explain this a little bit by bit, but effectively r/n then is effectively saying new line, and I can't remember what the R is for, but I know there is an outdated Unix type thing, so that is something I will look up shortly. We're going to have to specify then what we want the content type to be, which is of course going to be, it's going to be HTML. So let's do that now. If I could type, that'd be great. But yeah, I just want to, by the way, say thank you to everyone for watching the previous video, because it seemed to do quite well, and I think I know the reason why. It's because it's again, network programming always catches people's eyes because it's a fun little challenge, and I think it kind of teaches you a lot, and there's not much out there as well. I mean, Bij's guide is fantastic, but there's not many people out there who are kind of promoting it, and I think that, oh, for Pete's sake, if you're new to the channel, I do that a lot. I've got this bloody glove keyboard, which is fantastic, and it's good for, your hands and your ergonomics and such, but it's just constant, clicking the wrong buttons. So be patient with me, and I'll get there eventually. But yeah, quite literally then, okay, we're going to write really quickly, but here we're going to write a bit of HTML. Okay, so for those of you who have never done HTML, hypertext markup language, it's effectively, it's the content that you want to be on the web, okay? There's different elements of web programming, okay? So you have HTML, which, like I say, is your content. There's a bit more to it than that. You can create things like divs and such like that as well, headers, paragraphs, so on, okay? And bullet points. all that fantastic stuff you see on the web every day. But you can also have cascading style sheets. We're not going to do any of that, although it would be cool actually. Maybe we could do that in this video, or maybe in the next video, which is effectively, you know, you could in theory, what we could in theory do if we had enough time today, which I don't think I do, but if maybe in a future video, we could quite literally get this linked up to a folder with a bunch of HTML files, a bunch of, or a CSS file, and quite literally just serve that. And I think that would be of more value. I don't know whether we're going to do that today if we'll have time to, but you know, you can easily figure that out if you wanted to kind of go the extra mile with this. Didn't plan on doing it, but we'll see where it goes. Right, HTML. So this is effectively just a bit of HTML. Okay, so it's a bit standard way to do it really. So you have to specify if it's what document type it is, which is going to be HTML. We have to say, okay, we're going to start HTML, we're going to start the body, and then we're going to start the header 1, which is what we're going to use. And then we're going to just write our text and whatever we want to appear on our web server, which for now we're just going to make hello world, I guess. That seems good to me now. Let's just keep it the standard way that Brian Kernighan intended it to be. That's probably the best way to do it. So we'll just say hello world for now. And then for those of you, again, who are new to HTML, sorry if I'm patronizing people who are, who have been programmers for some time, but some people genuinely don't know this, and it's a beginner channel. So we end each section then. So for example, if you specify that something is a header, you have to specify when that header is finished then, okay? So we're going to say body /body to say the end of the body, and the same for HTML and /HTML. And then we're just going to do \r/n, and I think that is it. I think that actually should work. Let's see if we get any errors. We do, because I'm an idiot and I didn't include that at the end, and I spelled response wrong, which is a fantastic start. Yeah, so I think that's it. So in theory then, what I should be able to do, which I'm going to test now, is if I run this server, then I should get a message over the web through typing in localhost, and then whatever port number you are going to run yours on. So let's test that now. So let's give that a go. Right, I accidentally stopped recording and nearly forgot to show you guys what I'm doing. So, right, what I've done then is I've compiled the file. Okay, I'm not going to go over everything, but compiling just effectively means you have your program. We're going to create the output file, which is the executable that we can run. So if I do // and then we just do main, which is wrong, actually. I've just realized, and I realized I've missed something out, which is a big part of the program. So let's go back and sort that out right now. Right, so if we come down here a little bit, what we can see is that we can't specify what port we want for our program. So we're going to have to quickly come in by here, and we're going to have to say int argc, and we have to specify char arg, oops, if I could type, that'd be great. Arg, I can't type why can't I type the right key? There we go, that's great. Argv, okay, great. And if we come down to, where do I need to go? Fantastic. I almost hard-coded the actual port that I wanted to use. So, right, in theory, what you would have done, but then you could have actually run that program, go into the browser, and actually specify, and just type in localhost :3000. That would have worked. I think it was 3000 I just had in there, but whatever port number you had in there, that would have worked in theory, but we don't want to do that. We actually want to specify which one we're going to run on. So if I just go up to Clang again, and then we'll go, right, okay, now we can say, so we'll say 3000, and now if I go to, right, so if I go over to this, then I've already got it up ready. It's not working. Why is that not working? Got interrupted by a system call. What? Okay, maybe it's because it's already in use. That could be possible. So let's try something that will almost certainly not be in use. That was strange. Actually, it's not strange. It probably was in use. That's had issues again. Port 9000 surely can't be in use as well. Okay, I don't know what's going on here. Right, let's try 80. No, what's a ridiculous number that would not be in use? Let's say 8939. Surely that won't be in use. And there is a way you can check which ports are going to be in use as well. 8939. Oh, that's wrong. 8939. Okay, right, I got to figure this out then. I don't know what's going wrong. Right, I think I figured out what the issue is. I mean, I don't know if this will resolve it, but we'll give it a go. So what we need to do is string length, and then response, and so put that in there. Yeah, so something I should have done earlier. Again, I'm unwell. I'm blaming it on that. Something what I should have done effectively, where you've seen that was 13, that was specifying the amount of bytes that are going to be used. And because the message was previously hello world, I just left it there. So change that and that resolves the issue. So, well, hopefully it'll resolve the issue. So if we, again, go up a little bit to Clang, and then we'll do main, and we'll do 3000. This should, in theory, work. Oh. Let's give that a go. And there we go. Happy days. And I'm much lighter on the camera now. Fantastic. Okay. So, right. What did we do there then? Okay. Well, quite literally, we just served a very basic static HTML file over our server. And that is all I wanted to do, really. But we're going to take it a little step further because, I mean, that's just really just showing you the bare bones, what we can do. But you can see the, the usefulness of that, I suppose. I mean, like, but there we just sent a simple HTML file on a local machine. But you could imagine if you were running this program on a server, in theory, obviously, I don't think that would happen. I can't see a use case for that. But, you're really seeing or taking a peek behind the curtains there and kind of, seeing the usefulness of it in practice. So we can see, well, let's get the program back up because I think it's probably best to talk a little bit about it, really. But if we take a little look at this, then again, it's all this HTML that we just served. Okay, if you had it in theory where you had a folder there and it's serving a bunch of different HTML files and CSS, then that, of course, that can be very useful. Let's take it a little step further then and get it to actually respond to HTML requests. So let's take that a little bit step further. So let's do that now. Right, so before we get too far ahead of ourselves, I wanted to take a kind of a bit of a pause and rewind a little bit to talk about the differences between TCP and HTTP and what they are. Okay, now of course I haven't got a great deal of time to talk about them in great depth, and in all honesty, I don't know if I would trust myself to do that anyway. But the basics and the kind of the general idea then, okay, is that TCP is a reliable pipe of sending bytes or data between two different machines. Okay, so what do I mean by that? It's guaranteeing delivery. So when we send, say my machine is sending hypothetically to another machine, sending data to another machine, it's guaranteeing the delivery of that data, and it's also ensuring that the data is sent in an ordered manner, which is different to UDP datagram, but we're not going to talk about that. We've covered that in previous videos, okay? HTTP then, Hypertext Transfer Protocol, is effectively it's a layer that sits on top of TCP then, okay? So, we can send things like HTML over the internet using HTTP, and that is done in an agreed convention where we use HTTP requests like get, so get HTTP, and then you will send a 200 OK message back, which would be the response then, okay? So we're going to talk a little bit about that now, and we're going to effectively add that to our program, because all it's doing at the moment is it's effectively just sending a hello world. So all my program doing, all our program is doing, is effectively ignoring the browser's request, which is get HTTP. It's ignoring that entirely. It's just saying hello world. It's just sending that back out, okay? But of course, in practice, we would need to effectively read and then get rid of the HTTP request from the browser, which we will be doing using receive. Okay, so we'll store effectively, the buffer. We'll store the bytes from the browser into a buffer then. Okay, and then we will send back a properly formatted HTTP response to the browser effectively then, okay? So the browser only renders the page if it sees those headers. Without them, it doesn't know it's looking at HTML, okay? So that's something to note as well then, okay? So there are frameworks out there that make this a lot easier, okay? You know, you can use Flask in Python, which is something that I've used previously. It always infuriates me using those sorts of frameworks, in all honesty with you, and I think, you know, I can understand why people use them, because it's a massive time saver. Because in theory, you know, you're not going to have time, you know, I guess if you're learning C or you're learning programming and your aim is to get a job, you know, I don't think industry are going to find much value in this, you know. It's good to know. I think it's certainly good to know. So if you're doing this, you know, you kind of have an understanding of what's going on underneath, if that makes sense. You know, the worst thing that you can do sometimes is rely too heavily on frameworks. But Flask would be doing all of this. So they handle the HTTP. They're doing everything under the hood. Okay, so everything that we're going to be doing now, which is dealing with HTTP requests and so forth, okay, that is what we're doing, okay? So it's reading and parsing those text headers, okay? And these are our HTML headers here then, okay? So, you know, that's why we use this /r/n. And again, I don't know what the R stands for. That's bugging me, so I'll probably look that up shortly, okay? But quite literally, that's all we're doing then, okay? So there's no magic, it's just quite literally formatting over a TCP socket then, okay? So what we're going to do now is add receive. We're going to effectively store the bytes in a buffer, and we're going to do some other stuff, and we'll talk about that shortly. Right, so let's get to it then, okay? Right, so we're going to go to inside our fork, okay, and before our response variable, we're going to add in a few lines of code, which is effectively going to deal with our HTTP requests then, okay? So let's do that now. So the first thing we're going to need to do is create a buffer, and we're going to make this about the size of, well, we'll say 496, because this is what I've seen online. For those of you who are new to the channel, I tend to get most of these ideas just based on things I'm interested in. But something that I found really valuable is Reddit, believe it or not. I mean, it's like, it's actually, it's a blessing and a curse. You go on there and you sometimes wonder whether it's worth programming C, unless you're on the C_programming subreddit, in which case everyone is awesome, because it is just, yeah, it's everyone on there is, you know, they're constantly giving good solid advice, looking over people's code and such like that. So it's a good, nice environment. But then you'll see like the other kind of subreddits, and you know, there's so much hype around AI now, and you know, other kind of new programming languages which are up and coming, that it can make you wonder whether learning C is valuable. But I tell you something, learning C has been the best or the most fun that I've had programming since I started. When I initially was doing a bit of programming in C, I found that it was actually quite daunting. It's a great language, it's great for beginners, but I think the issue is if you kind of learn at the low level, like if you want to have an understanding of what's going on underneath, because you know there are some people out there, you may be one of these people who, you know, you're a math student or you're a kind of an engineering student, and you don't really need to learn, well, I suppose engineering you do, but you know, if you're a maths, if you're a data analytics guy, if you just want to, you know, deal with databases, you don't need to know this. There's value to knowing it, of course, like there is anything, but you don't really need to. So anyway, let's get back to what we were doing in the first place. So right, let's explain that first bit then. Okay, so creating a buffer. So it's a fixed size character array to hold the incoming bytes, so the incoming requests then, okay, from the browser. We're going to use 4096 bytes because it's typically big enough for a HTTP request. It's stack allocated, lives in the function, and then disappears when the child exits, when the child is killed. Okay, so that's that. So we're going to do new file descriptor then. Okay, so that's going to be the first thing. We have to specify wherever the file descriptor is. Then we're going to say where we're going to store it, and we're going to say the size of that then. It's going to be size of buffer -1, and then 0. Right, so we're reading the bytes from the socket into the buffer. The -1 leaves room for the null terminator. That's why we have that there. And yeah, that's that. I think that's fine. So that's good. Always good to have the man pages. So, you know, again, if you're a bit stuck, we can look at this. So we have received, so int socket, void wherever the buffer is, the size of the length, and then any flags then, which is the last integer. So you can see that up here. Okay, so that's what we're going to be using. Right, moving on then, we're going to say, right, buff bytes equals, and then I don't know what happened there. I'm touching something on my keyboard and it's just jumping. I don't know what's going on. I went to null terminator, so is that, I think that's \0. There we go. Okay, so effectively then, we're saying, right, just for like educational purposes, I suppose it could be useful to kind of print out the request itself. So let's do that now. We'll do printf, and then we'll do browser request, and then we'll just do new line, and we'll put buff here. I think that should work fine. Data argument is not formatted by a string, right? That makes sense. Oops. Okay, there we go. Right, so let's give this a little go then. Okay, so what we're actually doing now is we're actually receiving what the browser has given us, and we're going to print it out. So let's give that a go and see if that works. And hopefully it should, and we'll have no issues. Let's just clear this a second. Clang, do a little clang, main. We'll do 3000. The only issue that I have is that I've already got the browser open. So let's, in fact, that doesn't really matter. Let's just click enter and see what happens. So if we refresh that, then we do get it. Fantastic. And I don't know if there's any personal information in here, so I'll have to blur that out. But yeah, you can see here that we've actually printed out the information then. So it's, you know, quite useful, I suppose, just to see what's happening behind the scenes. So you can see browser request get HTTP 1.1, local host, and there's a bunch of different information on here, like cookies, connection. Yeah, so there's some useful stuff there. You know, I mean, I don't know what to really take from that. It seems to be working fine. Just shows what you know the browser will send to your server effectively. So it's quite useful. It's quite cool to see that. Now, what we could do is actually deal with different types of requests, which I think might be the next step forward. So let's have a little look at that. Okay, so a lot of useful information there. I'm going to blur that all out because I don't think, even though it's a local server, I think it's good practice to kind of cover that up. So for you guys, you can run in and see what it will give you. Right. Effectively, you know, the HTTP 1.1 then you would have seen is what page and what version of HTTP it's running. So the /, you would have seen like a / and then space HTTP 1.1. So it's running HTTP 1.1, and the / is just the root. So it's effectively the indexer. Okay. Then the local host then, of course, is, you know, whatever, you know, you're running around. So local host and the port number for me is 3000. It's going to show something like user agent, Mozilla 5.0, I think it was for me, which is what browser and OS then is making the request. So you also would have seen, you know, you wouldn't have seen, but for you, if you run on your machine, you'll see it will show me what device I was using and such like that, okay? So yeah, you know, there's a lot of good information there. So you can look at that yourselves, but I'm not going to show mine. So that's great. Cookies then, you'll see like cookie name and then a value and such like that, okay? Any cookie stored on the local host, it is sensitive. So, you know, again, that's why I'm blurring it. Effectively, the session tokens, okay, from other local apps running on the local host, okay, so on my machine. So that's effectively it, okay, you know, in terms of what the information that gives you, what information the browser gives you back. What I really wanted to go over quickly is effectively what, so we got /r and /n there, and I've looked it up. I forget where it is now, I've got it stored somewhere, as to what that actually means. And I wanted to go over it really quickly because it's interesting. Again, it's quite outdated actually, and you could get away with living the rest of your life and not knowing. So click off the video if that's the case, but it, you know, just to touch on it because I find it quite interesting. The /r is effectively the carriage return. It moves the cursor to the start of the line. So that's effectively from the typewriter era terminals. Quite interesting. Is it worth knowing? Probably not. And then the /r, which is something we're all familiar with if you've been doing C for a bit of time, which I'm assuming if you've watched these videos actually, you might be a beginner, but you'll understand the /n means new line. Okay, so that's all that means. It just means move the cursor down to a new line. So that's that. And then together then it's known as the carriage return line feed. Okay, so CRLF. So the HTTP specification, which by the way is something I didn't credit at the start of this video. Somebody made a fantastic post, which I'm going to link to because that's what inspired me to make this video, about effectively breaking down how to learn, you know, HTTP in C, and he just kind of give a nice breakdown. Oh, this is how I go about learning it. And he put I think somebody, I don't know if it was him or somebody else, but they put a link to the HTTP specification, and it requires this. So the /r/n. Requires that, so not just the /n. So most browsers are forgiven and accept the /n on its own, but sending the /r/n is correct and is what every real server will do then. Okay, so that's just worth keeping in mind. Also, as well, with the /r/n, we'll see one line on its own, which again I didn't explain earlier. So the purpose of that's effectively separating the headers from the body. Okay, so these are the headers that we've got. This is the body, and that one line then is just separating the two. Okay, so that's just worth noting. And I think that's it. Good analogy here, which I found as well. So your server and the browser share a single TCP connection. Think of it like a walkie-talkie. Only one side transmits at a time. Okay, so that's a general idea. For those of you who are old enough, and I'm counting 26 or older because that's my age, to know what a walkie-talkie is. I think most people do, but as kids, I don't know if you guys did, but walkie-talkies, if you've got one of them, you'll know what I mean. Right, when a browser connects, it immediately starts transmitting its request. The data sits in a kernel buffer waiting to read. If your server ignores it and just starts sending a response, a few things can go wrong. So the browser may still be writing the response while you're, the browser may still be writing its request while you're writing your response. So this causes a collision on the connection. On some systems, the operating system will refuse to let you send until the receive button is drained. So the browser expects to finish sending before it starts reading. If nobody reads its request, it can stall or close the communication. So the correct sequence in the child process, which we are doing currently, is we receive, so we read from the browser's request, store that into a buffer. Don't have to parse it for a simple server like we're doing here, but in practice you would. But you would drain it effectively, okay? And then we send then, so that's when we send our HTTP response back. So that's it for now. Right, so I thought really quickly what I would do is show you guys the Reddit post that I was referring to earlier. So it's by Dratch88, okay, so you can go ahead. I don't know who this guy is, by the way, but he just gave a really nice breakdown as to how we would go about learning how to create a HTTP server. So again, I'll link this in the description. You can have a little look at it and read of it yourself. So far, we have effectively completed, well, if you include last video, we followed along with this, okay, Beej's Guide. I did not see that before I created my Beej's Guide tutorial video, but it makes sense, okay, that's like kind of the standard, I suppose. You go to that guide if you want to learn the basics then in terms of creating sockets, binding them and so on. Okay, so we've done this, we've created the socket, we've binded the socket to an address, we've listened to on the address, we block and accept until a connection is made and so on. Okay, so we've done all this, that's fine. What we have also done is step one, which is effectively a hard-coded message, just effectively, given hello world over the browser, which we've done. Something that I want to do in the next video is these two parts. Okay, now there's a reason why I'm not going over them now, and I think it's just because this video will become ridiculously long, and it's going to take a lot of time, a lot of time for me to figure out how to do this myself, because this is not following a guide. This is quite literally just doing a bit of programming yourself. So I want to kind of take that away, play around with it, and then I'll come back with a video and we'll kind of work through it together. If you guys have enjoyed the video though, please consider liking, subscribing, commenting even, okay, whatever you prefer. We literally hit over 600 subscribers going back a few weeks ago, and I never thought that we'd even make it to half that, and let alone that actually in the short time the channel's been up. So again, thank you very much. For those of you who are new, the whole purpose of this channel is to create a bit of a community for new C programmers. So if you're enjoying, if you want to kind of stay in touch with this channel, especially when we're creating a HTTP server, then consider, again, following, subscribing, and I'll see you guys in the next video. Thank you guys, bye.